Question number 8. In the figure 6.54, O is a point in the interior of the triangle ABC. OD is perpendicular to BC. So this is our D. Here we are having OD is perpendicular to BC. Then OE is perpendicular to AC. So this is our OE perpendicular to AC. Then we have OF is perpendicular to AB. So OF is perpendicular to, this is our F. OF is perpendicular to AB. So we have to prove that first part, OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus C square. Since here OA square is given to us, OB square is also given, OC square is given. That means we'll have to join O and A, O and B, and O and C. So first thing what we'll do is join O and A, O and B, O and C. So this will be our construction. If you see the right hand side, we are having AF square. So AF square means we'll have to take this triangle, and we have BD square. So we'll have to take the triangle ODB, and we are having C square. So we'll have to take the triangle OEC. In all these three triangles, we'll apply the Pythagoras theorem. So let's start doing this one. In right triangle OFA, we'll have OA square equal to OF square plus AF square using Pythagoras theorem. So Pythagoras theorem. Why it is? Because angle F is 90 degree and opposite to 90 degree is always the hypotenuse. So OA will be the hypotenuse. So let this be 1. Similarly, we'll go in right triangle ODB. So in right triangle ODB, angle D is 90 degree. So OB will be the hypotenuse. Therefore, we will be having OB square equal to OD square plus BD square. OD square plus BD square. Here same reason you will write Pythagoras theorem. So let this be second one. Then third one, in right triangle OEC. In right triangle OEC, angle E is 90 degree. So OC will be the hypotenuse. So we will be getting OC square equal to OE square plus EC square. And let this be third one. And this is also by Pythagoras theorem. So this also by Pythagoras theorem. And now what we'll do it, we have to obtain this one. We need to prove that OA square plus OB square plus OC square minus OD square minus OE square minus OF square equal to AF square plus BD square plus C square. So from the first one, we'll obtain the value of AF square. So therefore, from 1 we have AF square will be equal to OA square minus OF square. So let this be fourth one. Then from second, we have what we need? We need BD square. So BD square will be equal to OB square minus OD square. So let this be fifth one. Then from third we have what we have from third. From here we need C square. So EC square will be equal to EC square is equal to OC square minus OE square. So let this be sixth one. Now we'll add 4, 5 and 6. So adding 4, 5 and 6. Adding 4, 5 and 6. We have AF square plus BD square plus C square, that will be equal to OA square, and we can write plus OB square plus OC square minus, we can write in any order, what we required is OD square. So minus OD square, then minus OE square and minus OF square. So this is the proof of first part. Now let us do second part. So in second part, we'll take the help of the first part. what we need is need to prove is that AF square plus BD square plus C square equal to AE square plus CD square plus BF square. But in first part we have already proved that AF square plus BD square plus C square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OF square. That means what we need to prove is that AE square plus, because these two has to be equal. So that means AE square plus CD square plus BF square should be the same as OA square plus OB square plus OC square minus OD square minus OE square minus OF square. In that case these two will be equal. So from the figure if you see it that AE square, so AE square is equal to OA square minus OE square. So we are having here this OA square and this is minus OE square. So together it will give us AE square. Then how can we obtain CD square? CD square can be obtained by OC square. See in the figure in this triangle, OC square minus OD square, that will give us CD square. So this is our OC square and this is our OD square. Together it will give us CD square. Then how can we obtain BF square? BF square is a very simple one. For that we will go in this triangle OBF. So OB square minus OF square. OB square is our OB square minus OF square. So that will give us BF square. So second part can be proved, and second part will be your self trial. So second part will try on your own. This is self trial question. Self trial means you have to try on your own. Question number 9. A ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. So the ladder is 10 meter long and reaches a window 8 meter above the ground. Suppose this is the ground and this is the ladder. So this is A, B and C. So this will, because house is always straight, so this will be 90 degree and window is here at point A and the height of the window is 8 meters. So this is 8 meter and the length of the ladder is 10 meter. So this is 10 meter. Find the distance of the foot of the ladder from the base of the wall. So we have to find the distance of the foot of the ladder from the base of the wall. That means this is our foot. So we have to find BC. BC is required. So it's very simple one. What we'll do is we'll use Pythagoras theorem. So applying Pythagoras theorem, applying Pythagoras theorem in triangle ABC, applying Pythagoras theorem in right triangle ABC. In right triangle ABC, we have AC square equal to AB square plus BC square. Therefore, 10 square equal to 8 square plus BC square. So this will give us 100 equal to 64 plus BC square. Therefore, we will get BC square is equal to 100 minus 64, and that is BC square equal to 36. Therefore, BC equal to 6 meters. So the required distance of the foot of the ladder from the base of the wall is 6 meters. Question number 10. A guy wire attached to a vertical pole of height 18 meter is 24 meter long. So here we are having a pole of height 18 meter and at the top of the pole a wire is attached from point A to one point on the ground, that is C, and the length of the wire is 24 meter, and we have to find the distance of the point C from the point B. So it's a very simple one. What we have to do is we have to apply Pythagoras theorem. So we will be here opposite to angle B. We know if angle B is 90 degree, opposite to that will be hypotenuse. So here we will apply the Pythagoras theorem, that is AC square equal to AB square plus BC square. So in right triangle ABC, what we will be getting is AC square equal to AB square plus BC square because of Pythagoras theorem. So whenever And how we got that this is 90 degree? Because it's given to us pole is 90 degree. Pole is vertical, so it will be 90 degree to the ground. So we can apply Pythagoras theorem whenever there is a right triangle. We can always apply Pythagoras theorem. And here AC is given to us, so we will be putting the value of AC here. So that will be 24 square equal to AB is 18, so 18 square plus BC square. Simplify this and we will be getting the value of BC. In question number 11, there are two aeroplanes. One is moving towards north and one is moving towards the west. The one that is moving towards north is having a speed of 1000 km per hour, and the other airplane is having a speed of 1200 km per hour. And we have to find the distance between the two aeroplanes after 1.5 hours. So what we'll use is, we'll use the formula of distance. Distance equal to speed into time. So for the first aeroplane, that is OB, OB will be equal to D equal to S into T. So here the speed is 1000 and time is 1.5. That can be converted into 3 by 2. So 1000 to 3 by 2. So cancelling 1000 and 2 will be getting 500. So 500 to 3, 1500 kilometer. So OB will be 1500 kilometer, and similarly OA also will apply the same formula of S into T. So for the other airplane, the speed is 1200 kilometer and 1200 km per hour, and the time is the same, that is 3 by 2 hours. So we will be getting OA equal to 1200 into 3 by 2, that is 1800 km. Now we have to obtain AB, and this is a right triangle, and therefore we can use here Pythagoras theorem. So AB will be equal to square root of OA square plus OB square, that is equal to 1500 square plus 1800 square. Now both we can in the both parts we can write it as 15 square into 100 square plus 18 square into 100 square. Then we can take out, because 100 square is common in both the parts, so we can take out 100 square out of the square root. So we'll be getting 100. So simplifying this one, we'll be getting 300 root 61 kilometer. Therefore distance between the two aeroplanes after 1.5 hour will be 300 root 61 kilometer. Now let us go in the next question. Question number 12. This is very simple one. In this there are two poles. One is 6 meter and the one is 11 meter, and the distance between them is 12 meter. We have to find the distance between the top of these two poles. So what we'll do is, we'll draw AC, a line parallel to ED, and then what we will get is ACDE will be a parallelogram or a rectangle. Then the length of AE will be same as CD. Therefore, if AE is 6 meter, length of CD will be also 6 meter, and it is given to us BD is 11 meter. So we will be getting BC as 11 minus 6, that is 5 meters. Now we will go in right triangle ACB and apply Pythagoras theorem. And opposite to angle C is always, angle C is here 90 degrees. So opposite to 90 degrees always the hypotenuse. So we will be getting AB square equal to AC square plus BC square. So therefore we will be getting here AB square equal to 5 square plus 12 square. 5 square is 25 and 12 square is 144. Adding them we will be getting 169. Therefore we will get AB equal to 13 meters. Therefore distance between the tops of the two poles will be 13 meters.